to get started. Welcome everybody. So this is Nitrates in Omaha and Northeast Nebraska. Just to make sure you're in the right room before we get started. That's what we're going to talk about today. So I am excited to introduce Dr. Shannon Bartlet-Hunt, who is here today. She is the Donald R. Voelte Jr. and Nancy A. Keegan Chair of the Department of Civil and Environmental Engineering at the University of Nebraska-Lincoln. She received her BS from Northwestern University and her MS and PhD from the University of Virginia. Her research focuses on understanding physical and chemical transport processes for contaminants in soil and water, including steroid hormones, antibiotics, and microplastics. Her research has a particular focus on contaminant behavior in agroecosystems. So I'm going to pass it over to you.
Thank you.
Thanks for being here.
Yeah, thanks so much. I'm really pleased to talk to you all today. I'm hoping this will be interactive, so please just stop and ask questions. I have slides. I won't be sad if we don't get through all of them, so it would be great. If you have a question, just ask, or if something comes up at the end, that's great as well. So I'm going to talk to you today a little bit about nitrate and try to put it in the context of my background a little bit as an engineer. But as many of you probably know, we have many communities surrounded by agriculture, and nutrients are not just coming from agricultural production, but we use a lot of nutrients in lawns, in municipal and urban systems as well. When we have excess nutrients, that's where we start to run into issues with potential degradation of water quality. So we need nitrate and phosphate specifically. Those are the nutrients that we're focusing on our citizen science project. But we can have excess of those, and I'm gonna kind of reframe this to talk about how nutrients cycle and water cycles in our environment. So when we have excess of these, that can lead to degraded water quality. And of course, we also know that we need good water quality for public health, right? So we drink water, we recreate in water, we do lots of things with water. And not only we need water, but also the environment needs clean water, animals, etc. So there's lots of reasons why we're concerned with nitrate. This figure shows nitrogen flux. So that basically just means like the flow of nitrogen in the continental United States. And if you can kind of generally pick out where Nebraska is, you can see we're in a very, very dark brown area, dark orange to dark brown, just showing that we have a lot of nitrogen, right, in our watersheds. And that's predominantly coming again from this use in agricultural production. So again, I'm an engineer, so I like to solve problems. And something that I think is great to kind of frame this is that this group, the National Academy of Engineers, has identified these global grand challenges. So if you kind of think about what are engineers working on in the future, this is at least some things that some smart, preeminent engineers have come up with for us. But two of them, number 1, 2, 3, 4, and number 5, managing the nitrogen cycle and providing access to clean water, are directly related to what we're talking about today. So I think that's just really important, that this just isn't a challenge that we have, but it's really a global challenge, and it's one that's going to take a lot of different skill sets to solve. So first, I'm just going to talk a little bit more generally about clean water. So some of this definitely relates to us in Nebraska, but some of it is just globally. We could say, okay, we have excess nutrients, but we also have a ton of water, right? So why does it necessarily matter if we have nutrients in our water? And so one thing I want to convey is that we really, even though we do have lots of water, especially in Nebraska, globally, this is a grand challenge because we do have significant parts of the world without access to clean water supply. Lack of clean water leads to a lot of health consequences. And then the flip side of clean water is sanitation, right? So again, in Nebraska, we don't often think people have poor sanitation, although across the US, there are definitely communities without access to good sanitation, but then also globally, we have this issue with sanitation, which can affect our water supply. Going back now, maybe to 4th grade, 3rd grade, use the water cycle, but something that I think is really important because again, we look out at our landscape and we say, there's lots of water, right? I see the Missouri River and I see creeks and streams and ponds all across Omaha. I know we have a lot of groundwater resources, so we have a lot of water, which is true. But again, if you kind of look at how much of our global water is available, I want to convince you that we actually have pretty limited freshwater resources. So again, here's the water cycle. So if you look at where most of our global water is stored, it's obviously in oceans, right? So about 97.5%, you can see those percentages there, of our water on Earth is in oceans. Just about 2% is tied up in glaciers. And so really the water that we have left to use is this little bit of surface water and this less than a percentage of groundwater. And then if you look at our groundwater, a fraction of that is so deep below ground that it's essentially inaccessible. So we really have less than 1% that we can use for all of the things that we need to use water for. And that's kind of shown in that picture over on the, I guess, left, your right, showing that top box is just all the water on Earth that's predominantly in oceans. The next white box shows the fraction, again, that's in glacial ice. The next box, the light blue box, shows that fresh water that we do have, but that is too deep to be accessible underground. So it's really just that tiny little pixel at the bottom. That's the water that we have to use for everything that we need to be using water for globally. And again, this is just another way of representing the same thing. You can see the size of the Earth. If you kind of pulled all that water off of the Earth and made that blue ball, that would be all the water. And then our fresh water is just that tiny little pinpoint. So even though we do see a lot of water, we don't always have a lot of water that we can actually use for the things that we need to use it for. And what we use water for varies, again, globally. So this is a map, I think from the UN, and just showing by sector how much water is used. And so you can see for where we are in North America, we're using a lot of water for agricultural production, but the light blue arrow is our domestic water supply, and then the dark blue arrow is water that we use for industrial production. And then what's not represented there is also just water that we have to have in the environment to have a clean and healthy environment, which is important for all of our health, right? So we don't necessarily think about that as a use of water, but it is definitely something that we need to have water available for environmental functions as well. Here's a total aside, a little poll for you. So as an engineer, I think this is important to talk about. We'll talk a little bit about water quality. So my question for you is, which one of these water sources is healthier for you, better for the environment? Bottled water? Tap. Anyone want to vote for the bottled water, which is fine. Everyone here is a tap water. Okay.
Tap water.
Tap water. And so I agree with you, but why is that? Yes, in the back.
I remember PG said that like the water was better than like some city, and so the city looked into the water, and like PG water has high levels of arsenic, and so he looks like waters for waters.
Yeah, so I think that's one really important thing is that most bottled waters often are coming from municipal water sources. So it's really just, it might be filtered, but it's coming from a municipal source. The second thing that you kind of touched on is it's regulated by the Food and Drug Administration as opposed to the FDA. And the Food and Drug Administration regulates water differently. So they're more focused on like outbreaks of disease that might be caused by something, but not the regular testing that EPA, subjects water to. So your tap water is tested much more often. Cost is huge, right? So does anyone know? So you usually do this with students that have no idea what you pay for water. Does anyone know roughly what you pay for a gallon of tap water? It's way less than a penny, I'll tell you that. So you'd have to have 20, 30, 40 gallons before you might get toward, a cent. Bottled water, I think I calculated it out the last time I talked with high school students, and I think we said it was somewhere between $6 to $8 a gallon, if you bought those bottles at 99 cents for, 8 ounces or whatever. So your cost is different. And then last but not least, right, you can talk about plastics. So then there's a lot of plastic involved with how we use and supply bottled water. So for all of those reasons, that's just my little plug for our engineering infrastructure. Yes?
And you're all not also getting microplastics in your bottled water, the drinking it.
Yes, that is one thing that people are starting to find, right, is those bottles, when you're opening and closing them, or just maybe the manufacturing, that yeah, there are plastics in those plastic bottles that you might be consuming. Definitely with tap water, there have been issues, right, with lead. And so that's something that's really important. I saw a later topic talking about lead, and that is critical, right? We have a lot of lead service lines, and a lot of people that may be being exposed to lead through service lines, but that's really from the infrastructure in the home, right, that needs to be changed out, not necessarily from the quality of water that's coming from the treatment plant. So, great, preaching to the choir here in terms of what water to be drinking. Okay, so then the other side of this, that's kind of my why, we don't have, even though we have a lot of water, we don't have a lot of clean water. The other kind of big picture aspect of this is managing the nitrogen cycle, right? So we talk a lot about managing like carbon. I don't think we always talk about managing nitrogen. And so why is nitrogen out of whack? Really kind of goes back to World War I, development of the Haber-Bosch process, which allowed scientists to basically develop ammonia from atmospheric nitrogen. So if you go back to kind of the traditional way nitrogen was meant to be, it was mostly supposed to be in the atmosphere, right? And so we started taking it from the atmosphere, making ammonia. I think at the time they wanted to make bombs, which they were successful doing, but also we could use it to now fertilize things. So this totally changed agricultural production because we didn't have to just rely on nitrogen that was naturally occurring in soil. We could add nitrogen to the soil, but it really shifted where nitrogen exists from being predominantly in the atmosphere to now being predominantly on the land surface or in water. So we apply ammonia-based fertilizers all across the state of Nebraska. Those get converted to nitrate by bacteria. So if you're a chemistry person, I put a couple of equations up there to show that these are bacterially mediated processes. So we have ammonia converted to nitrite, and then nitrite converted to nitrate, again by different groups of soil bacteria. So that nitrate can then be taken up by plants, but typically it either isn't 100% taken up by plants, or if it's applied at a time when it's raining or close to raining, right, then you might have some of that nitrate wash off. And so that excess nitrate then washes off soil into water. So how does nitrate get into our water? There's lots of different ways. We talked about that surface runoff. And so again, that can come from agricultural production. So our little cow back here is an example, but it can also come from urban settings as well, right? Because we use fertilizers on our lawns and our grass. It can come from industry up here, so there can be industrial sources. It can be deposited here, and also there's combustion that puts nitrogen back into the atmosphere, and then it can be deposited. It can come somewhat from our wastewater treatment plants, right? So they have permits to treat wastewater to certain levels, but there's still some presence of nitrate in their effluent. And then what happens when this nitrate is on the ground is it either can run off into our surface water, or it can be taken up by plants, settle into sediment, be taken up by organisms, can grow algae. That's one of the big issues with environmental nutrients is it can cause algae to bloom, and that uses up the dissolved oxygen that's in water. Or it can go into our aquifers, which is predominantly what we're using, I don't know where my arrow went to, predominantly what we're using for our drinking water supply, right? So about, I think 88% of Nebraskans are drinking groundwater. So health impacts of nitrate, why are we concerned if we have nitrates? And I will say the EPA has set what they've determined to be a safe limit of nitrate at 10 milligrams per liter. But some of these impacts have been shown at lower concentrations of nitrate. The level of 10 milligrams per liter is really based on health impacts like methylglobinemia, which is blue baby syndrome, which is really where the nitrate in blood can affect like the uptake of oxygen, right? And so infants, if they have too much exposure to nitrate through things like maybe using formula made with water containing nitrate, then they can actually turn blue. But some of these other things have been associated with nitrate exposure, things like Alzheimer's disease, thyroid function alterations, different types of tumors, etc. So, as we know, our public health is very dependent on our environmental health, not just with nitrate, but with many other environmental contaminants. So this is just a map of the United States, just showing kind of two things together. One is the level of nitrate combined with the potential vulnerability of your aquifer. So does your aquifer have, the potential for that nitrate to be transmitted down into the water that people will actually be drinking? So red means high nitrogen, high vulnerability. Green means low nitrogen, low aquifer vulnerability. And again, what do you see right where we are in Nebraska, right? We're sitting on a very, transmissive aquifer with a lot of nitrogen. And so nationwide, the USGS has estimated that about 20% of wells contain at least one contaminant that is has potential health concerns. And the challenge here is that when people are drinking from private wells, there's not a requirement or regulation to test your water. So again, going back to tap water, that's tested very regularly for hundreds of different contaminants, biological contaminants, chemical contaminants. Private wells, it's really up to the homeowner to test. That can be expensive, kind of a daunting task. How do you do that? So definitely yearly tested is recommended. And that's kind of where our citizen science program comes in, trying to provide some of that preliminary information to people about the quality of their water. So getting to Nebraska, the state does collect information on water quality and groundwater quality, but this is a map that just shows that we don't have information from a lot of places, right? So this is a map for the state of Nebraska, and each pixel just tells you the median concentration of nitrate in that township, which is why it's a square. And so green is kind of below 5 milligrams per liter. Yellow is around 5 to 7. And then as you get darker, you get higher. So 10 is the orange, light orange to dark orange is where 10, that's the drinking water standard, sits. And then anything that's red or kind of purple is well above the drinking water standard. But gray means no data, right? So you can see that there's quite a few places in the central part of Nebraska, but also over where we are in eastern Nebraska, where we just don't have information on groundwater quality. So this kind of brought us to our citizen science program. So starting back in 2018, we wanted to provide people with an opportunity to measure nitrate, both in private wells, but then also because many people in the eastern part of the state are on municipal water supplies. People want to know about the quality of the water just in the environment where they live. So we also wanted to test surface water as well. So we've recruited quite a few people to measure surface and well water quality a couple times a year. We've partnered with Conservation Nebraska, which is, I think, part of the reason that I got invited to speak to you all today, which I'm happy about. And then we do provide training as well. So we can do in-person training sessions for groups. We also have some videos to show people how to collect the water samples and do our testing. I will tell you this at the end, but I will also tell you now, we're signing people up right now because we're doing a testing window in May. So if you would like to be a water quality tester, go to that website. You can sign up should get a QR code and just let you fill it out, but sign up. There's a web form where you can sign up to become a water quality tester. So how this program works, and I think why it has been pretty successful, is it is very simple, right? So if you're signing up to test, you might say, what am I getting myself into? You're getting yourself into about, depending on where your water sample is, 5 to 10 minutes of effort. You've got to get to the water you want to test. But we'll provide you with 2 test strips. One is for nitrate and nitrite. So it's a colorimetric test. You dip first you get your water sample, right? And so that is one thing when people are testing surface water, we obviously want them to be safe, not get in the water, collect your water with a buddy. Or if you're taking a water from your tap, if you have a private well, we have some instructions on run your water for a certain amount of time. But once you have your water sample, it's really straightforward. You dip this strip into your water, you hold it flat for a minute, and then you compare the color against these color charts. So let's just do a little test, and some people are colorblind, so we definitely acknowledge that can be an issue. So for this strip matches to nitrite, which is just another form of nitrogen. What concentration do you think that is reading compared to the color strip? He wants to hazard a guess. 0.3? Yep, bingo. So see, you're already trained. You can do this. And then nitrate, where would you put that one? Probably about 5. There we go. And that is as simple as this is. So we have a data sheet where you can just circle or mark your level of nitrate. And then we have you can either mail that back, some people like to do that, or you can just enter your data in a web form. And then it comes back to us and we can aggregate it, across the entire state. Same thing, there's another test, which is for phosphate. It's similar, it's just measuring phosphate. The colors are a little more differentiated, but again, you just dip your strip in water, measure, and then map to the color chart that you're provided. So in terms of the data that we get, so this is some of the data from the spring of 2023. So interesting, like who's participating. We get about 2/3 of people testing their wells, which is great because this might be kind of a point of entry for them to test their home drinking water that's inexpensive. And then about 40% testing surface water, which is great, right? Because if people, again, are living in a community with a municipal water supply, we're not concerned that nitrate's gonna be an issue in their domestic water, but we would like them to go test what's in the environment. It just provides us information about what's going on in our surface water. So here's data. You can see the red circles are well water, the blue triangles are surface water, and then the size just corresponds to the concentration. So these last 3 sizes are really things that are getting close to the drinking water standard. And then for most of these individuals, again, what's nice about this data set is we have a lot of monitoring data. Like if I flip you back to this chart, this is not all domestic wells, right? This might be a combination of irrigation wells or monitoring wells, but this data is coming from people's domestic well. And those are wells that are hard to measure as scientists because they're inside people's homes. Yes, do you have a question?
Do you have any idea what percentage of private wells versus all the private wells in the state?
Like what percentage are private wells versus all wells?
No, the percentage of testing that is done on private wells versus the total number of private wells in the state.
Yeah, I don't know, but because it's not required, I think it's a relatively small number. And I probably will give you bad information. You can look at the state does do a report on groundwater quality, and they have a broken out section on domestic wells, and it's a pretty small fraction of the total wells that are being tested. Does that make sense? So I don't want to give you a specific number because I can't remember it off the top of my head, but it's relatively small. So that's one of the things that we think is valuable about this because it provides people with information right away, and then also we can aggregate it back to look at information across the state, both for surface water and groundwater. Something that we've been trying to do is partner with different NRDs, so that's why we're including how many different NRDs participated, and then we have some partnerships like with Conservation Nebraska with some specific NRDs where they're sending out testing kits to like every registered well owner, which is great. They can use this as kind of a screening tool. And then this isn't complete data, but partial data from through the fall, kind of the same thing, same split of well versus surface water. And so you kind of see, yes, there are definitely dots here in this 5 to over 20 range where we are concerned about how much nitrate is present in those groundwater wells. So in terms of participation, we don't do a ton of advertising of the program because it's literally like 2 of us, so we don't have capacity for like thousands and thousands of participants. But we have several hundred participants every time. This is how many samples were submitted, and we do have some people that test more than one, so it's not one person per sample, but you know, we get several hundred data points every time we test, which is great. And I think part of what makes people excited about this program is how easy it is to participate. It's very straightforward and very simple. And then this is kind of a lot of data, but this just shows you for the wells on the top, I'll try to point this out, what percentage were below 2 milligrams per liter of nitrate, 5, above 5, above 10, and above 20. And so the number that we kind of really focus on is this drinking water standard of 10 milligrams per liter. And you can see this kind of comports that we're around 20-ish% of wells are testing at or above the drinking water standard for nitrate, which means that people are drinking water with nitrate in excess of what the EPA has determined to be safe. So what we try to do in those cases is point homeowners toward first confirming that data. So this test, as you can see, is kind of semi-quantitative, right? You're picking these color boxes, but it goes from 5 to 10, right? So if you think it's 10, maybe it's 7.6, right, which isn't on there. So we first try to encourage people to follow up with some additional testing, but it's kind of a screening, so they can have some more information, try to connect them with a certified laboratory, and then also connect them with resources for how they can address nitrate in their water if it does turn out to be high. Yeah.
So you get spring and fall, you don't test for summer?
Yeah, so we have just started, we started this in 2018, trying 3 times per year. So kind of spring, summer, and then fall was actually later, much later. And I don't think people want to do things when it's cold. So we kind of went to, you could really think of it as like May and September. And part of that was more for, we don't expect groundwater to be that changeable over time, but part of it was for the surface water. We see kind of seasonal differences in nitrate. So we just went to those 2 testing windows because winter, we really don't want to be outside, but even that late, like October, we were just seeing a real drop off in participation. Yeah, question? And then
But if you got your well turns out to be high level nitrates, that's not cheap to you.
no, and so it's not, but I think it's really important that first people know that that is an issue. Follow up with a certified test, which is maybe $12-ish to get it retested, but I think for a lot of people, then the remediation, like how do you actually address it? Right now, for example, there's a RO, I think, rebate program through the state and DEE, so trying to point people toward those kind of resources.
A lot of them switched to, my family farm way back when, 30 years, switched to rural water
Yeah,
because it was too, but the thing that bothered me was they kept their animals on high nitrate. And to me, that was going to cause problems with the pigs and hogs and
potentially, yeah, just
horses, and they were being,
exposed to that nitrate as well. Yeah,
it's going to cause them as much health problems as what humans.
yeah, could be, although then we're gonna kill them right before they probably get cancer or something, so they're
There's
going.
been in the paper that around, I'm trying to think of the North Bend, not North Bend, but up the Platte River quite a bit, that there's been a lot of north of that, people, we should quit calling me. And they're opposition. They would not admit. They said, I don't care, I've been drinking this water all my life. Why am I worried about it now?
Yeah, I think that's kind of an unfortunate attitude, right? And I think that, you know, there's a lot of
Call you back.
resistance, sometimes from farmers being viewed as the problem, right? But I think all of us play a role, right? Because we all want inexpensive food. We all, you know, so I mean, we have all kind of supported that, and just the economics of the way we grow food now kind of necessitate this really intensive, you know, agricultural production. So it's really hard to just say, well, it's all, you know, the part of farmers, because we all want to go to the grocery store and not spend, you know, too much money. But I think there's some of that, but I do see people starting to have a little bit of a changed attitude that yes, this is a concern, and maybe some of it comes from, hey, maybe I've been fine drinking this water, but I don't know that they always want their grandkids and things like that drinking, you know, drinking the water as well.
Even the NRD board, the person who was realized that there's a problem with nitrates got voted off the board.
Yeah, and I think it has been slow. I mean, this is one thing I think Nebraska now is starting to have some recognition of the issue with nitrates, but it's been slow coming, right? So people have been talking about this for 20, 30 plus years, so it's kind of been a slow developing.
Isn't there some occurrence, it's not proven, between juvenile brain cancer? Yeah, so again, that's some of those things. If you go back to that slide on health impacts, it's not directly like a causation, but you can see brain tumors there have been linked with nitrate exposure, and then we have, you know, high rates of that in Nebraska. It hasn't been documented or proven.
Correct, but there could be some. Yeah, with any type of cancer development, it's complex, right? It's going to be genetic, environmental. I mean, there's many factors. Okay, there's a question here, question there, and the question in the back. So go ahead.
I was wondering, our refrigerator has the filter system on it. How good is that for getting impurities out of that water?
Yeah, so that is a great question. So most of the fridge filters are some type of activated carbon, typically. That's probably not going to remove much nitrate, but it could remove other things like atrazine or organic chemicals. RO is a treatment process, so sometimes people will put those under their sink. That's kind of an all-purpose, you know, treatment, so that will remove just about everything. So it just kind of depends on what you're concerned about, whether it will remove that or not. Okay, there was a question in the back, and then I think over here. Yeah.
So you've covered about the effects of fertilizer, excessive fertilizer on cropland. What about the effects of confined animal feeding operations? Does that have any impact?
Yeah, definitely. So that's right. So I kind of was addressing this, like talking about the Haber-Bosch process, talking about commercial fertilizers, but also, you know, we have a huge amount of animal production, and that manure typically is land applied. It needs to go someplace, and so there are processes in the state like manure management plans and application plans, but really that manure largely does get applied to land, and so that is another source of nutrients. It's also a source of other things that I study, like antibiotics and the chemicals that we give to animals for growth promotion. And so it's again one of those issues with intensification, right? We have to grow a lot of animals in close confinement, and then we have a lot of manure. Definitely there are best practices around when to apply manure. You know, don't apply it to frozen ground, things like that. But definitely that's an issue where most of that manure is being applied to land. Yes. Yes, a question.
Yeah, I was just gonna ask, how long does it stay in the watershed when it's coming from especially field runoff? Is main window gonna catch, especially like springtime fertilization?
Yeah, so our main window kind of catches, we hope, that sort of peak
Runoff.
first flush, I guess, kind of like where it's been sitting maybe on the ground surface, and then it, you know, the first rains kind of carry it into water. I was gonna say something else. But the other thing I was gonna say is like the groundwater issue. If you look at what's happening with groundwater, that's kind of slowly moving down. So we're kind of probably haven't hit the peak nitrate yet because it's moving slowly through soil down to ground. So once it's in soil, if it's not being utilized, like once it gets past the root zone, it's kind of there. And so then just what happens when it keeps raining, it's just gonna keep slowly moving down toward our aquifers. Yeah. Yes?
You've been following the series of research articles that Flatwater Free Press has been doing on the nitrate levels in Nebraska.
Yeah, somewhat, yep.
I think the Nebraska Supreme Court recently denied them access to a bunch of public information regarding nitrate contaminants. Wants to charge them like $44,000.
Yes, I think that was the biggest thing. Yeah. Yeah, so I mean, I guess as far as like, I think that may have just, I think there was just a bill maybe passed about limiting those fees that state agencies can charge for those public records requests, which is probably good for all of us as just citizens. Yeah, I mean, in terms of the issue with nitrate, I think again, there are definite potential linkages with agrochemicals and really negative human health impacts like brain tumors, for example. And so I've been part of a group with UNMC that's looking at some of those linkages with different agrochemicals. There's nothing, again, because cancer development is very complicated, probably never gonna say, yes, this is 100%, right, from environmental nitrate or atrazine or some other agrochemical, but there's probably a combination of factors. Really quickly, I was just gonna say, if you wanna read something really kind of interesting, Iowa just did a study, I don't know if you saw this, where they actually linked their high rates of cancer to binge drinking, the nitrate that is formed when you binge drink, which seems a little tenuous to me, but I'm kind of ignoring the other elephant in the room. But so it's definitely an issue that's in a lot, and that wasn't a scientific article, that was like a news article that was being released by the state. Okay, there's a question here, and then,
Iowa linked it to what?
Binge drinking.
Oh.
Yeah. And they do have apparently high rates of binge drinking and then high rates of cancer development, but then they also have a lot of, agricultural production. So, yeah. So go ahead.
Well, I was just going to say to the study that UNMC did, if I understand the findings, they did find a geographical correlation between high pediatric cancer rates and the nitrates in Nebraska's water. And there is peer-reviewed research, sir. It was published in the summer of 2022. And if you want to find that, I would refer you to the article that the woman to your left, Flatwater Free Press.
Yes.
Just type that in and nitrate. They have including map layovers that you can actually see some of the maps that you showed today along with overlaid with cancer rates. So for those that are interested,
thank you.
A lot of really great work.
Thank you. Another question in the back. Yeah, go ahead.
It's more of a comment. There's a joke in Iowa. 75% of the streams in Iowa are impaired to nitrates. The other 25% haven't been measured yet.
Yeah, I mean, I think that gets back to some of the questions about data. Another reason why we are excited about citizen science, because it really can be a tool to collect more information, maybe in places where we don't have as much access to. I think that's a great point. And then, of course, talk about public press, right? This huge nitrate spill that just happened in the Nishnabotna River, and almost a million fish were killed. So you can talk about human health impacts, but then there's also these really dramatic environmental health impacts. So, is there another question in the back? Yeah.
I just noticed that the nitrate levels in 2023 spring and fall were way lower than the rest of the times. Is that because practices have changed?
Oh, spring and
water data.
Oh, probably not.
Okay.
Probably just more the variation of who's testing and when. Yeah, no, I mean, I can't say that it is or I can't say that it isn't. Yeah, probably maybe just more a function of who's collecting and when. Yeah, but those are the types of things with more data that we hope to be able to actually, maybe tease out, which would be great.
Do different forms of nitrogen when applying matter? So if you're using ammonia versus urea?
That is a good question. I think this is kind of where my knowledge gets a little hazy, but I do think there are some more available forms of nitrogen, and that's actually one of the arguments that people make for manure nitrogen versus chemical fertilizers is they are more available for plant uptake, which can be a benefit then, because then more of them are taken up and.
That is runoff. But
Yes, exactly. So yes, I think there is. I don't know if I'm an expert on what exactly those are. Other question? Yeah.
So like throughout the summer, I'll check. I think it's the NDEE site. You know,
Yeah.
if I want to go paddleboarding or out to the lakes,
Yes.
and they're not checking nitrates. But are you guys collaborating with them? Is that something they could be collecting that sample too?
Yeah,
because
I
they do
think
it all.
so. Some of like this data comes from the this database. This is groundwater,
Right.
but I think they also have some surface water databases, and we have started some initial talks with trying to put citizen science data in some of those databases. But definitely, there's a difference in data quality. So you wouldn't necessarily want to make a regulatory decision with citizen science data, but it can maybe add to the total available information. Yeah.
You were talking about manure. Do you do a lot with educating with green manure?
I personally do not. Yeah. I'm more of the person who's out there collecting it, looking for different chemicals or contaminants. But I mean, I do have colleagues in extension that do a lot with manure education. And we do have a lot of it, and we need to use it for some things. I mean.
Oh, I was just wondering how that information with green manure impacted nitrate levels.
Yeah,
Since they can fix nitrogen naturally.
Sure. Yeah, I'm not totally sure. It's a good question. Yes.
Well, this may be a little off your topic, but
That's okay.
I noticed there's some encouragement with new laws for more regenerative agriculture, in fact, designed to improve production as well. But that would seem to take in part of this. And part of, I think, of good regenerative practices is to have a buffer zone around your fields.
Yep.
No fence road in the road.
Yeah. Yep. Yeah, and those types of buffer strips or best management practices actually have a host of benefits. So one of the things is they can kind of filter out contaminants from moving across that edge of field, and not just dissolved contaminants, but also different types of contaminants as well. So things, even some of the things that we study that aren't regulated, like pharmaceuticals or steroids, that's a practice that kind of can benefit all of that. So even though it might be geared toward one thing, it has other benefits as well. Yeah, question?
I think that's part of why I'm struggling with a lot of this, because it's not like, there's no real mystery in a lot of these processes. Like you apply excess nitrogen to your field and you get rid of all of the native vegetation, and then you end up with nitrate infiltration.
Yeah.
So what's the next step here? Like, what do you think, in terms of your expertise, like where do we go from here? It's one thing to say everybody's responsible because everybody wants food. It's another to say,
how do we fix
80+% of the agriculture in this state is feed corn, and we have farmers who don't actually care about any of it, and we're all suffering. So like,
yeah, I think that, so I guess what I would say is there's probably technical solutions for everything, right? So like if you want to just treat water, we know exactly how to do that. So I think where the challenges come in is it's the cost. And I think one of the biggest issues with this type of runoff is it's not end of pipe, right? So there's no way to necessarily collect it and charge the cost of treatment back to, does that make sense, where it's coming from?
it's not a point source, right?
And then a lot of the health effects are external costs, right? So if we're sicker as a population, right, yes, we pay as individuals like our health insurance costs, but we're also just, so I have struggled with what is exactly the solution, because technically I think we understand the problem like you said, right? But yet coming up with a great solution is pretty challenging. So I think if you can figure that one out, you've managed the nitrogen cycle and you've solved that global engineering challenge. You probably get a Nobel Prize.
The example, when I was born in 1955, there were 2.5 billion people on the planet. And in this short time, there are over 8 billion. So you had to increase the amount of food on the areas that were growing.
Absolutely.
Because at the same time, housing, cities they're eating up the farm ground, and they eat up the best farm ground cause they need large sources of water that are easy access. I think, I don't know, it seems like the more educated people are, the smaller the families and all that, I think. You know, but, it will not, it's not gonna go away unless the population drops, cause the demand is gonna drop. I
Right,
mean, I
and then
don't mean
that's a whole,
that's a whole
problem
different thing,
too.
but,
Yeah.
it's just a fact.
Yeah, so I mean, the solutions we always think about are education, regulation, and technology, right? And some combination of those, and I don't think we found that mix, so.
I just wanted to offer for people that are interested in current research, Doherty Water for Food, which is part of UNL, is constantly doing research, and on their website, you can just, if you're interested, you can look at research that is current and it's just been published and stuff on this topic.
Yeah, how do you spell that?
DAUGHERTY. Okay. Doherty Water for Food Institute.
So I'm happy to answer more questions, but I'm gonna put up my shameless plug for citizen science participation. So again, we're recruiting. And what this continued monitoring allows us to do is start to maybe look at some of those trends over time, or gather more information that can then be put together to give more information. So, but again, happy to answer more questions, and I appreciate all of your time and the great questions we've had so far.